Hi folks, Dr. P here. This is Math 20-2 Quadratic Equations, Topic 5, Example 2 on page 45. So in this example here, I'm only going to do A, and the difference between this example here and the previous one, example 1, is that if we look carefully at the quadratic equation here, on the right-hand side, we don't have a 0. Here we have a 3. We have 2x plus 6. In the previous examples, we had a quadratic equation on the left equaling to 0. Okay, so how will this change our approach to solving this quadratic equation graphically? Well, there are two basic ways we can do this. We can either, so the first way would be get rid of the 3 to have this 3 equal to 0. So set right-hand side, so the right-hand side is 3 here, set it equal to 0. How do we do that? Well, we can subtract 3 from both sides. Okay, if I subtract 3 minus 3 is 0, and then I'm going to end up on the left-hand side, negative 5 minus 3. So if I do that, I'm going to get x squared minus 2x. So negative 5 minus 3 is negative 8 equals to 0. Now the right-hand side is 0. So we can go ahead and solve it exactly the same way graphically that we did in example 1. The second approach would be to graph left and the right-hand side separately. So graph left-hand side and right-hand side separately. Okay, what does that mean? It means that in our graphing calculator, we're going to be graphing this is the left-hand side. We're going to graph this as y1, and we're going to graph this as y2. If we pull up our graphing calculator and we go to y equals, we can see that we can graph several functions. And in this particular approach number 2 here, we're going to be graphing y1 as the left-hand side. So it's going to be x squared minus 2x minus 5. That's the left-hand side in the equation. And then the right-hand side is going to be y2, which is 3. Then we graph it. And now what we're going to get is we're going to get our quadratic function, that's our left-hand side, and then we're going to get, in this case, a horizontal line, that's our right-hand side. And to find the solution here, we're looking for the points of intersections. Specifically, we're looking for the x-coordinates where these two graphs are crossing each other. And our graphing calculator can help us find those x-coordinates. So we're going to go to second, trace, and we're going to choose option 5, intersect. And just like in the previous example where we were solving, or we were finding the x-intercepts, so where the quadratic was crossing the x-axis, when we're looking for the intersection points, we need to do this twice, once for the left-hand side and once for the right-hand side. I'm going to start with the left-hand side. First, it says here, first curve. So we see that this cursor here is blinking on the quadratic equation, which is our first curve. So that's okay. Enter. Second curve. Now this little cursor is blinking on this horizontal line, which is our right-hand side. So that's our second equation. So that's correct. We just press enter, enter. And here is the x-coordinate of this intersection point, is negative 2. So we can say that x1 equals to negative 2. And then we also have to find the second intersection point. We have to repeat this. Second, trace, intersect. And now we see that when it says first curve, this cursor is indeed on the first curve. But maybe you're thinking, well, when we found the first root here, so x1 equals negative 2, why did the calculator pick this x-coordinate and not this x-coordinate? How does it tell them apart? Well, when it asks you for the first curve, not only is this cursor blinking on y1, that first curve we entered, it also needs to be as close as possible to the intersection point we're looking for. So right now it's close to this one. So if I would repeat this process again, it'll find this intersection point again, which is, we already have it. We're looking for the second one, the right-hand side here. So I'm going to move this cursor closer to this second intersection point by moving it to the right, like this. Right? So it doesn't have to be super close, but we want it to be closer to the point we're looking for than to the other point. So somewhere over here will be sufficient. So that's first curve. Second curve, well, it already placed this cursor closer to this point, so we don't have to move it. Just enter, enter. And the second solution, the x-coordinate here is 4, so x2 is 4. Then they also want us to graph it. So I'm going to put in my y2 first. The y2 was a horizontal line going through y equals 3, so right there. Okay, then my roots were -2, so it's crossing this horizontal line there, and +4, 1, 2, 3, 4 over here. Okay, and if I look at the graph again, I see that it's a minimum, it goes down. My minimum point is going to be somewhere over here. And then I can draw the quadratic function like that. And that's a wrap. I'm going to let you guys try to do B. Remember that you do have the answer, the keyed answers to the workbook online. We also have office hours. Make sure you attend those office hours if you have any questions. So until next time, stay safe, stay healthy, and may the math be with you. See you.